Welcome back, everybody. We are looking at exercise 3 on page 7 in this video. Let's take a minute just to read this problem together. So when a spring is stretched, the amount of elastic potential energy stored in the spring is given by the function E equals f of x millijoules, where x is the distance in centimeters that the spring has been stretched beyond its natural length. Okay, use the graph of f shown to the right to estimate the average rate of change of f on the interval from 0 to 5. Okay, and after we do that, we would like to explain the significance of our answer in context. Okay, so let's take a minute just to talk about the information that we're given here. Okay, so this is a graph of energy. Notice that energy is on the vertical axis, and they give us units of millijoules. I'll just abbreviate that MJ. And then x is the distance that the spring is being stretched in, let's see, what were those units? Centimeters, it looks like. Okay, so you can see that the farther you stretch the spring, the bigger the energy is getting. Our graph is telling us that. Okay, well, what would we do to calculate this average rate of change? Well, we have a formula for that. It's basically measuring the amount of energy change over the amount of length change in this case. So the average rate of change is just going to be f of 5 minus f of 0 over 5 minus 0. It's like calculating a slope. Okay, now how do we do this calculation? Okay, because notice they don't give us a formula for this function. They just kind of give us a way of thinking about it. Energy is a function of x. Okay, how do we figure out what f of 5 is, for example? Well, we really have to do it graphically in this case. We don't have any other way to do it. So 5 is our input value. We can find it here, and then f of 5 should be the value of E there. So we just have to estimate that as best as we can. And what do you think? What does it look to you like the E value is? And if I had to guess, I'd say maybe in the neighborhood of 125, okay, for f of 5. Okay, and then we come to f of 0. What would that be? Well, here's x equals 0, and we can see that our energy level is 0. Okay, our output is 0 if we plug 0 in. And in the denominator, we just have 5 minus 0, which is 5. Okay, so put it all together, we're going to get 125 over 5. That's going to give us an answer of 25. Okay, well, we've answered the first part of the question. That is our average rate of change, but what does it mean? What are we really measuring when we do that? Okay, well, let's think units here. Okay, so in the numerator, we were talking about outputs, okay? And we can see from our picture that output values are E. Those are measured in millijoules. Okay, and then the 5 minus 0, those are points on the horizontal axis. Okay, down here, those units are centimeters. So we can see that the units of the 25 should be millijoules per centimeter. Okay, could we put that into a sentence? They ask us to explain the significance. That means we'd like to give a complete sentence explanation of what we just found here. And the units might help us to do that. 25 millijoules per centimeter is suggesting a rate of change, how fast the energy stored in the spring is changing relative to how far we've stretched it. Okay, so we might say something like this. Okay, as we stretch the spring, okay, and notice that we stretched it over this interval from 5 to 0, so from 0 centimeters to 5 centimeters, we're getting, okay, an average rate of increase of energy stored in the spring of 25 millijoules per centimeter. So we could maybe say it like this. The amount of energy stored in the spring increases at an average rate of 25 millijoules per centimeter. Okay, so it's just telling us kind of how fast, on average, additional energy is being stored in our spring as we stretch it over this 5 centimeter length.